Ever wondered how some programmers solve problems faster and write cleaner code? Welcome back, guys, to the Tech Tutor. Today, we're going to be diving into abstract data types, or ADTs, and how understanding them can take your coding to the next level. Stick around to see how they can make your code more efficient and easier to manage. Alright, let's get started with the basics. An abstract data type, or ADT, isn't about how data is stored. It's about what you can do with that data. Imagine driving a car. You don't need to know how that engine works to drive it. That's exactly how ADT works. They focus on the operations you can perform, not the behind the scenes details. So ADT is what you can do with the data and not how it is done. And for examples that we're going to see in today's slides: lists, stacks, queues, decks, sets, maps. These structures show up everywhere, whether you're navigating menus in an app or browsing your browser history. So why use ADTs? Why should we care about them? Well, they're the secret sauce to writing flexible, modular, and reusable code. Think about it if you're building a scoring system for a game using a list, but later realize a different structure works better. An ADT lets you swap it out without redoing everything. That saves you time and headaches. It's like changing the tires on your car without needing a new car together. Super convenient. So the encapsulation part, the modularity part, and the code reusability part. So let's break down some of the most common ADTs and how they work in real life. First up, we've got the list ADT. Basically a collection where the order of elements matters. You can insert, delete, search, and traverse through the list. Think of your Spotify playlist. You can add, remove, or rearrange songs. That's a list ADT in action. Okay, so a list ADT, as you can see also in the code or in the bottom right over here, it shows the actions that a list could do: inserting, removing, deleting, searching, and traversing through the list. So it could be done with arrays or linked lists. Next up, coming to the stack ADT. Stack, we want to think last in, first out. Imagine a stack of plates at a buffet. You always take the top plate first, not the bottom one. If you take the bottom one, all of them are gonna probably fall down. That's how stacks work in code. And we're gonna, in the next couple of videos, we're also gonna have a more deeper look into each of these data structures individually. But here's some basic introduction. So some operations that we could do with a stack. You could add to the stack, you could push on the stack, or you can pop from the stack. You can remove the plate from the stack. You can peek on the stack. You can see what's on the stack, and you can see if it's empty. Right? So in use cases, you could undo features in text editors, backtracking algorithms, and you can do it with arrays or linked lists. Next, coming to the queue ADT. So the queue, you want to think of it as first in, first out. Okay, think of waiting in at your favorite coffee shop or a restaurant, and the first person in line gets served first, right? Some operations with queues, you have enqueue add, which is to add, dequeue, which is to remove, peek is empty. Some use cases where we could use this is task scheduling, print queues, call center systems, and it could be implemented with arrays or linked lists. As you can see in the code bottom right, it's summarizing what we could do with queues: enqueue, dequeue, peek, and check if it's empty. This is super useful when you need fair processing and no cutting in line. Remember. So comparing ADTs, let's have a look comparison time. It's stacks. Stacks are great for backtracking. Like when you hit undo in an editor, it's great for that. Queue, it's perfect for scheduling tasks or handling incoming data. Lists are ideal for ordered data when you need random access or iteration. Okay, so each ADD solves different problems. They're made for different problems. So choosing the right one depends on what you're trying to accomplish. Again, stacks using arrays, queue using linked lists, dynamic list resizing, some implementation examples. So here's the deal. Understanding ADDs help you think like a developer. You stop worrying about how things are built and start focusing on solving problems. Whether you're prepping for coding interviews or building your next big project, knowing when to use an ADD can make or break your code. ADDs define what you can do with data, not how. They help you write cleaner, more adaptable code. Essential knowledge for interviews and real-world coding. And trust me, interviewers love throwing ADD questions your way. If you found this helpful, make sure to hit like, subscribe, and hit that bell button so you don't miss out more on beginner-friendly coding tutorials. If you have a question or a topic you want to learn about, drop it in the comments below. And remember, my unmatched perspicacity coupled with sheer indefatigability makes me a feared opponent in any realm of human endeavor. See you next time. Take tutors.